Okay, we are now live.
Vibin, do you want to get it started, or you want us to just introduce the...
First, if you can introduce yourself, and then we can continue, and in the last we can take some questions.
Yeah, I'll just give a quick overview of the project and the idea concept behind it, and then I'll let everyone let everyone here introduce themselves. So the idea behind the project is that telecom roaming agreements are legal agreements. Usually they are bilateral agreements, and usually it's lots of legal terms, but there's also a technical side of it as well, commercial. And the concept here is we are trying to tackle this at the early stage of building the telecom roaming agreements, which is at the stage of drafting and negotiation. And we came across the concept from other domains. Actually, in financial markets, there's this over-the-counter derivatives agreements, which is looked to us something similar. And there's already something similar in the financial market that handles something in the domain of how to draft and negotiate a kind of master agreement. So the concept is to use both natural language processing and DLT. In this case, it's Hyperledger Fabric. The natural language processing is to analyze the text of different legal agreement documents and try to classify the text into different parts, and Santiago will go through this. And then the DLT is to manage the automation piece and ensure the trust and the auditing and the traceability. Myself is Ahmed Sghayer. I work in blockchain industry for the last 3 to 4 years. I build blockchain solutions, and I asked both Nuruddin and Mohammed to join me because they can bring the other side of the project, which is the natural language processing, which is their specialty. And Santiago is the mentee in this mentorship project, and he was the one performing all this work while we provided him with guidance throughout the project. So I'll leave it to Nuruddin and Mohammed, and then leave Santiago as the last one, since he's going to be doing the entire presentation. So, yeah. Nuruddin?
Thank you, Ahmed. Hello, everyone, and welcome to this meeting. My name is Nuruddin Sadawi. I'm from Libya, based in London, UK. I'm a senior lecturer at the University of London and instructor with O'Reilly and Pearson. I specialize in machine deep learning and those areas, so that's why I was invited to co-supervise this project. I'd like to thank Ahmed and Hyperledger and Linux Foundation for facilitating this. It's been a really good project. Santiago has done a fantastic job, as he will present to us today. I'm grateful also to Mohammed for his contribution. It's been a really nice and useful project. We've learned a lot along the way. And yeah, thanks everyone again for joining us. Over to you, Mohammed.
Hi everyone, this is Mohammed El Sharif. I'm a software engineer at Qatar Center for Artificial Intelligence. I'm mainly work in applied machine learning and deep learning under spectrum of applications, and I'm involved in many projects with local and international entities. We have collaboration projects with Boeing in predictive maintenance, in detecting small objects, and also we have a collaboration project with MIT about urban computing, and with Qatar Airways in local entities. So that's why Ahmed, he asked me to join this project, because I'm working in machine learning and deep learning, during my career for the past 5 years. So thank you, Ahmed, and it's over to you, Santiago.
Okay, thank you very much, Ahmed, Noreddin, and Mohammed. Let's start it. Okay, good morning, good afternoon, good evening for everyone. My name is Santiago. I recently finished my PhD. I am currently working in data analysis and information management group of CEIT, that is a research center in Basque Country that is part of the University of Navarra. First of all, I would like to thank to the special Telecom group for the invitation to the present work, the use of NLP and DLT to enable the digitalization of telecom roaming agreement as part of the Hyperledger Mentorship 2021 project. Additionally, I would like to introduce to my mentors projects, Ahmed, Noreddin, and Mohammed, who were present in the call and talk a bit before me. So you can see the Menti project presentation on the link placed, in the slide footer. And now I will start with one overview of the roaming agreement concept. Roaming agreement operation ensures business continuity and ubiquitous service access to the end customer across various technologies stack, including, for instance, new technologies like 5G, IoT technologies, and IoT. The roaming agreement addresses the technical and commercial components necessary to enable the service to a roaming customer so that it constitutes an essential part of the business, managing issues such as, the interoperation shares. Thinking that roaming agreements are mainly, a bilateral agreement with an established template provided by GSMA. Therefore, conducting a dynamic and transparent roaming agreement drafting process ensure advantage for telco companies in terms, for instance, of monetization. The necessity of the project comes from problems detected in the roaming agreement drafting process, which includes, first of all, the roaming agreement negotiation is manual, slow, and untrustworthy. The second one is that the GSMA approach for the wholesale roaming initiative is like generalist in terms of negotiation and drafting of the roaming agreement. So it lacks of standardization. So there is a necessity to establish a framework that provides capabilities such as, a fine-grained methodology that digitalize the roaming agreement drafting process. In addition, the promotion of a transparent negotiation process between two mobile networks operators, and in addition to ensure traceability in the roaming agreement drafting process. In this way, blockchain integrated with other technologies such as natural language processing can cover these capabilities. An overview of the project can be found in the first Medium article that we published as part of our project, and the URL is included in the footer of this slide. For this reason, the two main project objectives are, first of all, to build a library that will capture the different variations and variables that construct a telecom roaming agreement, and in addition to build a proof of concept based on a set of smart contracts that will automate the process of drafting and negotiation. In general terms, we can think in this project that looks very early phases of the roaming agreement and specifically the drafting and negotiation process. Our solution can facilitate the process of drafting an agreement and turning it into digital format can help in establish a root of truth of the agreement. For this reason, we first collect a few agreements, including the GSMA template, and build a simple NLP model to extract the main feature of the text, which that we classified as standard class, variables, variation, and custom text. This model then is used in the drafting of any agreement to build each article where the action of user are managed through the chain code in terms of article proposal, article change, until the entire agreement is finalized. At background level, we want to analyze, on the one hand, the NLP technology and the Amazon Comprehend tool, but a quick concept. In this term, natural language processing is a subfield, of linguists and computer science and artificial intelligence, concerned with the interaction between computer and human language. At the same time, Amazon Comprehend is a natural language processing service. It's like a tool that uses machine learning to uncover variables inside and connection in text. To understand what are variables, variation, and standard clause, and custom text, a snapshot of two documents are used. On the left side, you can see the AA12 GCMA template, and on the right side, you can see one sample of the mobile network operator Proximus roaming agreement. In this way, a standard clause implies to leave an article or sub-article as found in the template. Variables represent the value of certain attributes that are found in a certain text, such as, for instance, dates, name of entities, amount, and others. In addition, variation represents changing variables, for instance, mobile networks operator, dates, penalty, currency, and so on. Concerning the original text, I mean the GCMA template in the article or sub-article. Finally, customized text introduce completely new article or sub-article that respond to particular interests. The reference architectures include not only participant entities, but also the functionalities that they perform throughout the application lifecycle. First, the entities participant in the roaming agreement are composed by two mobile network operator and the GCMA as administrator. There are functions that they perform in common, such as the maintenance of the Hyperledger fabric network and participation in the network consensus. But particularly, mobile networks operators negotiate and draft the roaming agreement among themselves, maintaining the privacy of the information and using the NLP engine to create a template which be used as part of the drafting process. In addition, the GCMA is in charge of the registration of the mobile network operator, the network monitoring, the auditing, the accountability of the roaming agreement conducted between the two mobile network operators. The application lifecycle is composed by 4 stages. The first one is enable the roaming agreement principle. The second one is the registration of both the mobile network operator and the roaming agreement. In addition, the third stage is the roaming agreement drafting process. And finally is the phase to reach the agreement. The first phase starts when two mobile networks operator enable the roaming agreement principle throughout a document that could be shared with the GCMA as a central authority. At this point, GCMA is able to create the roaming agreement output template using the NLP engine execution. The second phase is produced when the GCMA loads the roaming agreement output template to the platform to manage the roaming agreement. It must enable the mobile network operator who will be able to register themselves on the Hyperledger public blockchain platform before starting the negotiation and drafting of the roaming agreement. The third stage contains the roaming agreement drafting process. Although in this image, 3 processes are represented, any combination that include, for instance, add article, accept article, propose change in the article, and reject the article can be performed. Finally, the fourth stage consists of the proposal to reach an agreement as well as the acceptance of the roaming agreement by two mobile networks operators. The two main components of the project are, first of all, the NLP engine, and the second one, the chain code, which are discussed below. The overall architecture of the NLP engine is built over a Docker infrastructure, establishing as input the roaming agreement draft as well as the GSMA template. The processing layer is, a logic identified as the NLP engine, which include as output, the classification of the article in standard class, in variation, in customized text, and variables. A very important component in the NLP engine is the Amazon Comprehension Service. This service, as we mentioned, uses machine learning to uncover variables inside and connection in text. Throughout Amazon Comprehension tool, roaming agreement text is processed to extract, for instance, key phrases, entities, sentiment for further analysis. Details of the NLP engine can be found in the second Medium article published as part of this project. And again, the URL is included in the footer of the presentation of this slide. Sorry. This image or this slide illustrates part of the set of methods that can make up, the chain code lifecycle. The invocation of this method establishes the transition between the different states of the chain code. This transition takes place at three application levels. The first one is the roaming agreement level. The second one is the at articles level, and the third one is that article level. Detail of the chain code design can be found in the third Medium article published as part of this project, and the URL is included in the footer. To illustrate the operation of the chain code, the following figure or slide show the sequence diagram of the proposed agreement initiation method. Thus, the proxy module enable the interaction with other modules. The identity modules allow verifying the mobile network's operator identity. The organization module verified whether the mobile network operator exists and has been previously registered. The agreement modules perform the following functionalities. First, the generation of unique identifier for the list of articles. Second one, the generation of another unique identifier for the roaming agreement. The third one is that the status of the roaming agreement negotiation is set as a started roaming agreement. The status of the article negotiation is set at init, and the started roaming agreement event is emitted. Again, detail of the chain code implementation can be found in the fourth Medium article published as part of the project. Again, the URL is included in the footer of this slide. The project implementation is based on a set of microservices using Docker infrastructure. It should be noted how GSMA is the administrator and the maintainer of a set of services, including the front end, the NLP engine, the Kibana, Grafana, Prometheus, and Swagger. In addition, the two mobile networks operator include the functionalities to maintain and monitoring the ledger. One of the most remarkable points of this project is the integration with other open source projects that belong to the Hyperledger mentoring or mentorship program, specifically the project analyzing Hyperledger public ledger transaction and logs using Elasticsearch and Kibana. We include this project as part of our project, and in the demo it's possible to see this integration. Sorry. Now it's time to have a demo time. First one, you can see the transaction committed into the ledger once the chain code is installed and instantiated. The attempt to access for the user failed because GSMAs need to register it before. Now GSMA register admins and user of the mobile networks operator. The user one now is able to register, for instance, one mobile network operator. Now you can see how the transaction is committed into the ledger. Again, the user 2 is able to register the second mobile network operator. Again, when the information is provided, now can be verified how the transaction is committed into the ledger. Now the roaming agreement, let me stop here the video. As you can see here, you know, the mobile network operator number 2 proposed a roaming agreement registration. As you can see here, this thing represent the roaming agreement output template that was provided by the NLP engine. As you can see here, the roaming agreement is proposed, and here you can see how the pipeline created can show the roaming agreement is available between the two mobile networks operator. Now, the other user, in this case, the user 1 or the mobile network operator 1, need to confirm the roaming agreement. Again, the transaction is committed into the ledger. And now this mobile network operator is able to propose an article based again on the roaming agreement output template loaded from the NLP engine. Here, as you can see, a standard class is defined, variables are introduced, and in addition, variations are defined. Again, transaction is committed into the ledger. And now, as you can see here, you know, the article is added into the pipeline. One important thing here is that the mobile network operator that proposed the change cannot be able to accept it. So now the second mobile network operator is able to, for instance, to propose a new changes. Now the variables are changed, but accept the same variations. Okay, here it should be possible to see that how the status is updated. And now the mobile network operator number 1 is able to accept the proposition. Again, the transaction is committed into the ledger. And then new articles are added for the into the pipeline. This is a new article, and another article should be added into the pipeline. But again, one important thing, the mobile network operator number 1 cannot accept its own changes. So mobile network operator 2 accept the proposed change. Here, transaction committed into the ledger. The next article is accepted. The status change, and now this mobile network operator is able to propose, to propose that the roaming agreement be accepted. Just 3 articles into the pipeline, in this case, is enough, and now the mobile network operator number 1 can accept the proposal. Okay. As part of the project, deliverables include, a series of, of Medium articles explaining the main project vision, the main concept, and the proposed design approach. The NLP model that extracts the main feature of the telecom agreement, agreement template as, as a set of variables and variation. In addition, a chain code that automates and maps the business process of the agreement, drafting and negotiation. In addition, the architectural design document of the system. Also, we create a simple user interface as proof of concept that will show the step of the agreement drafting. And finally, we publish an academic conference paper with the main finding of the project. For the future works, we have included, to build a model based on one open source library such as, Spacey, because right now we are using the Amazon Comprehension tool. In addition to create a drafting library in JavaScript and package it and publish it as npm package. We also planning to ensure information privacy between two mobile networks operator through the private data collection. In addition, we want to contextualize the traceability of the roaming agreement negotiation between two mobile networks operator through the visualization tool. In addition, the definition and establishment of an audit and accountability layer for the system. Another future work is the full API for monitoring based on Prometheus and Grafana. And the last one is to submit a manuscript to, to the IEEE International Conference on Blockchain in 2022. At this point, I want to thank to my mentors, the knowledge and skill gained around this project. Thank you very much.